In today's video, we'll be writing system of equations from verbal descriptions. When writing a system of equations, you need to give a description of each variable being used. Both equations will share the same variables. That's a little bit of a typo there, but it's supposed to say both equations will share the same variables. We want to set this up to where any of our verbal descriptions is only going to use two variables, and they're going to use the same one for each equation. So we want to make sure that we pick our informations carefully. Our instructions say determine and describe the variables to use, then write two equations based on the descriptions provided. First thing you want to do is kind of read through everything, understand what they're talking about. The Maplewood Symphony Orchestra sold 146 tickets and collected a total of $1,036 in ticket sales. Admission was $5 for children and $8 for adults. Write two equations that would be used to find the total number of adults and number of children tickets. So this is kind of pointing us in the direction that we want to go to. We want to know how many adults and how many children are here. So since we know what we're already looking for, we can create variables for those two. Ooh, I can write that A a little better. Emphasis on the little bit. So A is for adult. And then C will be for child. More specifically, number of children. So let's just write it all out. Make sure that we know that we're talking about the number and not just one child or one adult. So the way we're going to take this information and create two equations out of it is to look at what information they gave us. They told us that they sold 146 tickets. So that's letting us know that the number of adults, because we are selling these in tickets, the number of adults plus the number of children need to equal 146. So in this case, this is the raw information that we get from this situation. We know that we're talking about number of adults and number of children tickets. And for this situation, there was a total of 146 tickets. So to be more specifically of what our variable are, it's not just number of adults, it's number of adult tickets and number of adult children. Now the other piece of information that we were given in this first sentence is a total. It says a total of $1,036. Now this is useful if we have a rate for how much it costs for each individual. That's where the next sentence comes in. It tells us that we have $5 for children, and it says we have $8 for adults. Each one of these are classified as a rate. So we can have this multiply to our variable. So for our adult, it says 8. And to show that it is a rate, a price, we multiply it by that many adults. And we do the same thing for our children. say positive $5, of course, so we show that we're adding these together. And it's $5 for every child. Now that we have our equation set up properly, we can say what the total equals. We know that it equals $1,036. And there we've created two equations. Our first one is just raw material. We know that we're going to be adding our adults and children to equal a total of 146 tickets. And then we have one that's about price. We know it's $5 for each child, shows us as a rate, 5 times C, and $8 for each adult. We have 8 times A, yet again treated as a rate. And the total of this should equal $1,036. Now, in our next lesson, we'll go into details why we would want to do something like this. As of right now, we are just setting up information for future lessons. Another way of looking at these is whenever we have a situation like this. It says that JP is thinking of two numbers. So we know that we are dealing with two different numbers and it doesn't give us any other information. So I can say X and Y, X being the first number, and Y being our second number. So this is going more directly into our math. It says the sum, which means we're going to be adding the numbers together, is 163, and their difference is 33. That means that we're going to subtract the two numbers. So if I want to show it as a sum, I show that I am adding the two together. And if I want to show the difference, I'm showing that I'm subtracting the two. Now when I add them together, my value ends up being 163 for my numbers. And when I subtract, my value ends up being 33. Now, depending on which order you put your variables in, will tell you which one is the larger value. Since I said that X was first, and this is a positive number, I'm saying X is going to be the larger of my two numbers. Yet again, will be important for future lessons. For right now, we are focused on setting up the two equations based off of the information given. Now, these are two simple examples of how everything works, but sometimes it'll go into money where we have to make ideas about how much each one is worth. So we have to refer to prior knowledge when doing this. Our first sentence says Mark has $4.95 in quarters and dimes. He has 3 times as many dimes as quarters. It asks to write a system of equations that could be used to find Q, the number of quarters, and D, the number of dimes Mark has. So in this case, it's already telling us what our variables need to be. It says D for number of dimes, and it says Q for number of quarters. Excuse me. Number of dimes. Ooh, Q's are hard to write by mouse. And Q will stand for number of quarters. Ooh, at this rate, I wish they picked a different variable. Ooh, I wish I had one of those writing tablets. That would have made this so much easier. Still would have looked just as bad, but it would have been easier to write down. So in this case, we know that the total cost of our quarters and dimes will equal $4.95. Now this is where the hint comes in, because I can't just say that my quarters plus my dimes equal the price, the value of them, because a quarter and a dime are worth different values. If it would have told us how many they had, then I could just use quarters plus dimes. But in this case, I have to use their worth. Quarters being 0.25, 25 cents, and dimes being 10 cents. So in this case, this is where we had to refer to some prior knowledge, understanding that a quarter is worth 25 cents and a dime is worth 10 cents. This is where understanding more information prior to getting to this point makes things a lot easier. And then our next part wants us to set up an equation. It says that he has 3 times as many dimes as quarters. So we know that when comparing to quarters, he has 3 times as many dimes. So this would be our two equations. In this case, we do not have a constant value. We simply have an equation where our two variables are set to equal each other based off of some value, some coefficient. And then our first equation, use prior knowledge, understanding that a quarter was 25 cents and a dime was 10 cents, to make the equation. So in this case, both of those created a different situation for us. More ways that prior information would work. Understanding that the perimeter means that we're going to be dealing with a length and a width. So we already know what two variables that we're dealing with. Just trying my best to write with this mouse. It's like trying to learn to write all over again. So reading this information, it says the perimeter of the rectangle is 89 centimeters. This we have to go to our prior knowledge or look into what the perimeter is. In this case, it would be 2 of our lengths plus 2 of our widths. So the full original equation is our perimeter is equal to 2 lengths plus 2 widths. Dealing with a rectangle, they both have 2 lengths and 2 widths. This one tells you what it is equal to already, it being 89 centimeters. The next sentence says that the length L is, this is where our equal comes into, 8 centimeters more than the width. So we show that we are adding 8 to the width. And that creates our second equation. This time it gives us our constant, but our variables are still on opposite sides. Now our problems can start varying up more and more depending on all the information that is in there. Number 5, reading the whole paragraph. It says the manager of a movie theater wants to know the number of adults and children who go to the movies. The theater charges $8 for adults and $4 for children. At the showing, 200 tickets were sold. The theater collected $1,304. It wants us to write 2 equations that would be used to find the number of adults and number of children who attended the movie. Now this one is set up a lot like our first one, but seems like a lot more information. It's another line worth of information, but it has the same thing. It gives us a total number of tickets. They charge differently for each adult and each child. So yet again, we're having our variables for A and C for the number of adults. Oops, almost forgot the A there. And our number of children. Now they're using the tickets to understand how many adults and children showed up. They're not asking specifically for the tickets. I'm getting slightly faster at spelling with this mouse. Gotta loosen the wrist a little bit. So in this case, we know the total amount is 200 tickets. So we know that all of the adults plus all of the children should come out to be 200 tickets. Now when we're talking about the cost, which says that they collected a total of $1,304, this is when they charge $8 for each adult and $4 for each child. So I can write my 8 as the rate for my adults. And I'm going to add this with the $4 for every child. And this equals a total of $1,304. So in this case, this gives the manager an idea of how many more adults show up or how many more children show up than adults, so they understand who they're trying to sell product to. So that's where you would go on with this information to figure out how many more of each adult or children showed up. The rest of the examples on the notes I'm going to leave available for y'all to follow along. This is mainly for my class that I'm teaching this to. But the idea is you need to make sure that you go through your information and mark everything down that you can.